Now we're going to take this function that we have, the same graph as we dealt with on the last example, except now we're going to take the x values and multiply them. So the first one I'll do in red, x values get multiplied by 2. Take a look at the points. This first point that was at -2 on the x-axis, -2 times 2, -4. The next point was at 0 on the x-axis. 0 times 2 is still 0. Next point is at 2 on the x-axis. 2 times 2 is 4. It actually overlaps with the next point we need to look at. That point at 4 times 2 would put it at 8. And last point is at 6 on the x-axis. 6 times 2 is 12. Would put it roughly about here. Connect them. And again, we get the equilibrium effect, except now the equilibrium effect is along the x-axis, not the y-axis. This function is y equals f of 1/2 x. Now again, like with translations, how those affect oppositely with the plus or minus, horizontal stretches also affect oppositely. So when we're multiplying by 2, essentially we need to put in 1/2 there for it to be the opposite. Second stretch we're going to look at is multiplying the x points by 1/2. So again, go back to the original blue graph. First point at -2 times 1/2 will put it at -1. Second point at 0 times 1/2 leaves it still at 0. Next point's at 2 times 1/2 will put it at 1. Next point at 4 times 1/2 puts it at 2. Last point at 6 times 1/2 puts it at 3. Connect them. And now we get the squishing effect of the equilibrium. The equation of this function, again, because it's a horizontal, we'll do the opposite of what we expect. We would expect 1/2, opposite of that would be 2.